Today we are going to see the ECG basics. First, the definition. Definition states that the graphical representation of electrical activity of the heart. As we know, our heart works as an electrical system in the body and works by the transformation of the impulses. The instruments which is used for this is known as electrocardiogram and the tracing is known as electrocardiogram. It was first introduced by Ethoven in the year 1901. Principles. The electrical activity get converted into mechanical form of the graph. That is, when the impulses travel from SN node to the AV node, from AV node to bundle of His, and from bundle of His to Purkinje fibers. These all electrical activity get converted into the mechanical form, and this mechanical form of energy is traces on the electrical graph. Now, the electrocardiograph paper. First, the vectors. We know that is x vector, y vector, and generally on the graph there are two axes. First, the x-axis and the y-axis. The x-axis denotes the time in second, and the y-axis denotes the voltage, that is amplitude in millivolt. On the ECG paper, there is some small squares and one big square. The big square contains around 25 small squares, and here we can see one small square on the x-axis denote around 0.04 second and on the y-axis around 0.1 millivolt. So one big square there are generally 0.2 seconds. Here we can see the constant space of ECG is around 25 millimeter per second. Now the leads in ECG. There are generally two types of lead, the augmented leads and the bipolar leads. The augmented leads are AVR, AVL, AVF. Bipolar leads are V1, V2, V3, V4, V5 and V6. There are total 12 leads in the lead system. The total number of chest leads is 6 and total number of limb leads is 6. What is augmented lead? Augmentation is generally putting a certain zero potential in the body. That is, the leads which are AVL, AVL, and AVL. Three leads are also used for recording the ECGs. Each lead measures the potential difference between an exploring electrode and an indifferent electrode, which is assumed to be at zero potential, and this electrode is generally placed in the machine. This indifferent electrodes is constructed by connecting the electrodes on the right arm, and left leg or foot together. This indifferent electrodes is called as V and it is assumed to be at zero potential since the sum of the potential in the leads should be cancelled out for the proper tracing of the augmented leads. Now, in the next slide, we can see the lead position of augmented leads, that is first the AVR. In AVR, the positive terminal it as the right arm, in the AVL it is on the left arm, and in the AVF it is placed on the left foot, while the negative terminal is placed in the machine, and from there the specific surface of the heart can be traced. Now, the chest leads position in the heart. Mason liquor generally gives the 12 lead placement with color coordination. We can see in the chart. We can see that the V1 is placed in the fourth intercostal space at the right sternum border. V2 is placed on the fourth intercostal space in the left border. V3 is in the equidistance between V2 and V4. V5 is placed in the fifth intercostal space in the mid clavicular line, and V6 is placed in the left mid axillary line. These are all the position of the chest leads. In the dextrocardia, these chest leads get converted and it is said as V1R, V2R, V3R, V4R, and the position is different from the given below. Now, there are certain specific definitions for the leads and which surface area of the heart shows the electrical activity. Like the lead 1 and AVL, it shows the superior left lateral wall. Second lead, third lead, and AVF show the inferior wall. AVR shows the right ventricular cavity. V1 to V6 shows the conductivity of the anterior wall. V1 V2 shows the right ventricle. V3 and V4 the interventricular septums. V5 and V6 the apex or the apical wall of the heart. The 1 AVL, V5 and V6 shows the left lateral wall. Here we can see that V1, V2, V3 and V4 shows the right ventricle and intraventricular septum respectively. And if we take the